Today's lesson is on pseudocode. So I can spell that there. And flowcharts. So as our code becomes more and more involved, you might find it handy to design your code using an English MATLAB hybrid and some pictures of showing how your code will flow and execute before you start actually coding it. Right? Now, for pedagogical purposes, we teach pseudocode and flowcharts late into the term because now you understand the tools that are available to you. You understand the if statement and the switch, and you understand the for and the while. These are the tools that you have. And now, knowing the tools, we can start to design our algorithm using pseudocode and flowcharts. So, pseudocode, again, is a hybrid of English and, in our case, MATLAB. Okay, in general, it's a hybrid of English and syntax. Now, I'm going to start with an example that we've looked at already, which was the myMax function. So myMax function took a vector v and returned the maximum value in that vector. We called it mx, I believe. And our algorithm, we started with length 4 vector. So let's say we have the number pi, and then we have maybe negative 101, maybe 10, and negative 5. So 10 here is the maximum. Our algorithm worked as follows. We initialized the maximum mx to be the first element in the vector, pi. And then for each remaining element, the negative 101, the 10, the negative 5, we compare that element to what's currently stored in mx. So we would compare next negative 101 to mx, which happens to be, I'll put in parentheses, pi at this moment. And we say, well, if negative 101 is larger than mx, then let's store negative 101 as our new mx. But it's not. So then we move on and we compare 10 to mx, which again is currently pi. And in this case, 10 is larger than pi, and so we would say, if 10 happens to be larger than pi, then we are going to make mx equal to 10. Okay, so now our mx is 10. And then we'd move on and we'd compare the negative 5 to mx, which is 10 now at this point. And negative 5 is not larger than 10, and so we stop and we output our mx, and our mx is 10. This is our myMax function that we coded up earlier in the term. Alright, well now I want to write some pseudocode for this algorithm. I want to write something that describes what we're doing here. And it's going to be a mix of English and MATLAB, and it's going to be technical and unambiguous. The format of pseudocode is up to you, the programmer, and there's really not any standard way of doing this. But it should be unambiguous. It should be very clear what it is that you're doing. So I'll start over here. I'll say, let's input input v. So it's nice to start the pseudocode by showing what it is that you are receiving, what your function is receiving. So input v, and then the next thing we're going to do is initialize mx to be the first element of that vector. So that defines the first, that defines mx. Then we'll say for each element in V beyond the first. And so for the second, the third, the fourth, etc. So for each element, we'll ask is V of I larger than mx? And if it is, if yes, we'll say mx equals vi. And then we'll end that comparison, and we'll end that for loop, right? For each element in V, we'll end that, and then we will finish the pseudocode by saying what it is that we output. We're going to output mx. So this is one example of the pseudocode for the algorithm, and it's very clear what it is that we're doing. Now, let me delete this here. Now let's look at a flowchart. I will make a flowchart for this algorithm, and I will start at the top and work, and it will flow down. So the first box of my flowchart, I'll say, let's execute our function. And again, what is contained in the flowchart is up to you, the programmer, but it should just be unambiguous, easily followed. So the first box, I can put, I'm going to execute my max, and I can say I'm going to output mx, and I'm going to input v. So this is the first box of my flowchart, and I'm going to always put the first box towards the top of my flowchart. Then I'll put an arrow. Say, after that box, what happens next? Well, I want to initialize mx as the first element in my vector. So we can say, well, we'll set mx equal to the first element. Okay. Now I've got a for loop here for each element in V beyond the first. So that means that I'm going to need the length of this vector. I need to know how many times to loop. So let me get the length of my vector. We'll say n equals the length of V. We'll put that in the next box. Now, I want to define this I, this iterator variable. And I is for each element beyond the first. So I'm going to set I equal to 2. And I'm going to ask a question now. And you'll see why I'm asking this question in a second. But I'm going to ask, is I greater than n, the length of the vector? Because we know we only want to iterate for each element in the vector. Once I becomes larger than the vector, then we stop with the iterations. So is I greater than n? Now notice any question that I ask, I'm going to put in this diamond box, in a diamond box. This is to distinguish between assignment statements, okay, and questions, branching statements. So from here we branch out now. Is I greater than n? If yes, well, let's do no first. If no, we'll go to the right. And I'm going to label that branch no. So I have to give my labels here. Yes, we'll say that's a yes. So if the answer to that is no, then what I want to do is compare the ith element in V to mx. So I will ask another question. Is Vi larger than mx? Again, notice that goes in a box. Is Vi larger than mx? If the answer is yes, we'll move to the right. If yes, then I'm going to set mx equal to Vi. I'm going to delete my pseudocode here to make some room. Okay, so if that's true, if Vi is larger than the max, mx, then we're going to set the new max to Vi. If not, we're not going to do anything else. So we're going to come back up here. So this is no. And we come back up here. And now I want to increment I equals I plus 1. So I want to increment the iterator and go back here. And look what happens now. Now we're going to ask, is I larger than n? Maybe, maybe not. If not, okay, now we look at that, the ith element compared to mx. Is that ith element larger than mx? If it is, we'll set that to be the new max. If it's not, we won't do anything, and regardless, we'll increase the iterator and go to the next element. Now, at any point when we increment I, if we have an I that's larger than n, then we stop. We stop. I think I'm running out of room here. So I'll say stop, return mx. So I want to kind of illustrate what it is that we're returning. So I'm going to put that in this last box. So notice that, to summarize here, my code has a flow that roughly goes from top to bottom. It's got one start, okay, the execute block, and it's got one stop, and it says what to return. And the flow is unambiguous. It's easily followed, and that includes after each diamond. Okay, the diamond paths are labeled no and yes, no and yes. So now let's bring up that example that we did. I believe the vector was pi. Then let's just say negative 101, 10, negative 5. Okay, so let's take a look at that example and let's work our way through the flowchart now. So we'll say this is V, and so when I execute my function, this becomes V, and we're going to set mx equal to the first element in V. So that is pi. So now mx is currently pi. Remember, the maximum is 10, so we need to be sure that after our flow, once we get to this box, the stop box, our mx should be 10. If it's not, we have the wrong flow. Alright, now we'll say n is the length of v. So n, well, I've got 4 elements in this example, so n is 4. Now let's set I equal to 2. Is I larger than n? Well, let me consult my table. Is 2 larger than 4? No. So I'll move to the right. Is v of 2 larger than mx? So this is v. So here's v of 2. Is that larger than mx? Let me consult my table. Mx is currently pi. So no, negative 101 is not larger than pi. The answer is no, so I'll go out the no path and around here, and I'll make I equal to I plus 1. So now I will become 3. And I can work my way back here. Is I larger than n? Let me consult my table. Is 3 larger than 4? No. So I go to the right. Is v of 3 larger than mx? Well, v of 3 is 10, and in my table, mx is pi. So is 10 larger than pi? Yes. Yes, it is. So I go to the right here, and I set mx equal to v of I. And I is 3, so mx becomes v of 3, which is 10. Then I come out this way. I'm not going to go down this way, because that's a one-way street there. So I'm going to go up here. I equals I plus 1. So I becomes 4. Come this way. Is I larger than n? Let me consult my table. Is 4 larger than 4? No. So I move to the right. Is v of I larger than mx? Well, I is 4, so v of I is negative 5. Is that larger than the current mx, which is 10? No. So I leave the flowchart through the no path, come up here, increment I. So I is 5. And I come down here. Is I larger than n? Let me consult my table. Is 5 larger than 4? Yes. Stop. Return mx. And I've got the maximum there. So it seemed to have worked. Now, let me go into MATLAB. Let's bring up the code. Again, you would normally do the flowchart and the pseudocode before the code. Again, but for pedagogical reasons, we teach the pseudocode and the flowcharts after you learn about for loops and if statements and so forth. So let's take a look at how now we would go from this flowchart to the code. Well, we've got, here's where, line 8 is where I have initialized mx equals v of 1. Okay, so we actually got the length first, and we called the length to be len instead of n. And then we got the initial mx, so we switched these two boxes. So you can do that. Either one of those boxes can come first. So we've got the length, and we've got mx. Now notice all of this stuff here. Let me get a different color. So this guy here, put an asterisk there. This guy here, put an asterisk there. And this box here. Those 3 boxes are all taken care of, so to speak, by line 9, by the statement for, and we called the iterator in this case I. Okay, in our flowchart we had called it I. For I equals 2 And again, we're calling the length n in our flowchart. For I equals 2 to n. So think about this statement now. Remember what this statement did. It set I equal to 2, right? And then it stepped by ones all the way until n, the length. So it sets I equal to 2. Okay, that's this box. Check. That's taken care of. Then, remember from the colon operator, it increments by 1. That's this box. Check, right? Check. We've got it. Then it goes all the way till n, and it executes that last n, and then it gets out of the for loop. That's this box. Check. So that one statement on line 9, and this is the key point here, that one statement on line 9 takes care of all 3 of those boxes in the flowchart. Then we ask in line 10, well, is that v of I larger than mx? That's this box here. And if it is, if the answer is true, then mx becomes that new v of I. Notice that we don't have an else, right? So there's nothing else to do if the answer is no. So then the yes and the no join up here, and we get to the end of the for loop. And at the end of the for loop, that again, that control statement, the for loop control statement, automatically increments I, and we go back up. So you can look at this flow chart and you can see that yes, we do have a loop here. Sometimes we're not sure if we need 1 loop or 2 loops or no loops, but you can see there's a loop here. Now, it's only 1 loop, and that's because, see, you might think right here is a loop. Okay, but here's the 1 loop. Here's the loop. There's the loop. Okay, this one, this small one here, that's not a loop, because a loop only occurs when you revisit a box that you've already visited. So if our answer is no, we're not going to come back this way. The arrows don't say to come back this way. Right? So if the answer was no, I'm not going to go this way and revisit this box. So this guy here, this small path, that is not a loop. The loop is this big one here, where if the answer is no or if the answer is yes, then they meet up and they come back this way, and then we revisit a box that we've already visited. So that is indicative of a loop. That means we need a loop there. Good. All right, let's go through a second example. There was another example that we recently did, which was a sort. We called it my sort. And it sorted a vector in ascending order. Ascending order. Okay, so our black box representation of this guy looked like this. So we had a vector v come in, and then we sorted it and we outputted, I think we call it vs. Alright, well let's try to write some pseudocode. But first let me remind you how the algorithm worked. Let's say I have a vector 100, 10, -5, -7. Now, we covered this in a previous video. Actually, it was the nested loop. There were 2 loops we needed for this. So I'm going to go through this fast. You can pause it or feel free to go back to the nested loops video. But basically, how the algorithm worked was that I compared, this is 10 by the way, 10. I compared adjacent elements in a vector. Right, so we looked at 110. Compare 110. And if the one on the right, since we're sorting in ascending order, was larger than the one on the left, we swapped. Swap. So then our vector became 10, 100, -5, -7. Then we make another comparison. We compare those 2 guys. And again, since the element on the right is less than the element on the left, we swapped. Swap. So now our vector would look like 10, -5, 100, -7. And then we would make another comparison, 100 and -7. And if the one on the right is less, then we swap. And in this case, we would swap. And so our vector, after the first pass, would look like this. The most extreme value, the largest value, the 100, bubbled to the right. This is called a bubble sort. So the 100 bubbled to the right, and it's in its final location. This was a for loop because we know how many comparisons we have to make, namely the length of the vector -1. We made 3 comparisons, and the length is 4. But our vector is still not sorted yet. We have to make another full pass. So long as we're swapping, we need to pass. And this was a while loop. So while we continue to swap, we execute the swapping routine. So I'm going to leave that up for now. We're going to write the pseudocode for this. So remember, there's nothing particularly that you have to have in your pseudocode. It's up to the programmer. But it should just be very clear and unambiguous. So we're going to input v. So our function now has v. And we're going to make these comparisons. So we'll say for, let me put some space here, for each adjacent pair in V, if right element is less than the left element, then we're going to swap the 2 elements. We're also going to set a swap variable equal to 1 to indicate that we've swapped. So we'll say swapped equals 1, and then we'll end that. Now, that is just this routine here. That's 1 full pass. We also need to keep doing this while swapped is 1. See, this is not sorted after 1 full pass. This is not sorted yet. Now the 10 needs to bubble to the last position. So we're going to say, while we are swapping, swapped equals 1. Continue to do this. So I enter the while loop. I want to I want to reset the swapped flag. Swapped equals 0. So I say, okay, swapped is 1, while swapped is 1. So now I'm going to reset the swap flag. Okay, I'm going to assume that I have not swapped on this pass. Now I'm going to make a pass. And if I do swap something, I'm going to set swap equal to 1, end my while loop. And then I'm going to look, did I swap something? If I did, then I need to make another pass. And once we have a pass where I did not swap anything, then I exit the while loop and I output, or I return, vs, which is equal to v at that point, because we're swapping the elements in v. So there is my pseudocode for this algorithm. I'm going to keep that example available to us. And I'm going to write the flowchart now. So I'm going to delete this pseudocode. So if I'm moving too quickly, or if I'm deleting that too quickly, feel free to pause the video. Right, now let's take a look at the flowchart. So we'll say execute, and we called this function mySort, and we're going to give it v, and we're going to return or output vs. So there's my execute block. Okay, after that, I'm going to define swapped, and I'm going to initialize it to 1 so we can enter that while loop, because now we'll ask the question, is swapped equal to 1? Remember, our questions go in these diamond blocks. So is swapped equal to 1? If it is, then I need to keep swapping. So if you look back at the flowchart, we'll say if it is, we're going to go to the right. So I'll label this as yes. And then if you look back at not the flowchart, the pseudocode, the first thing we're going to do is reset the swapped flag. Swapped equals 0. Okay, so now I'm saying, okay, this is the start of a new pass. I have not swapped anything in this new pass yet. Now, let's set I, the iterator, to be 1, so that'll keep track of where we're at in our comparisons. That's the iterator, set I equal to 1. So when I is 1, we're comparing 100, which is I of v of 1, with 10, which is v of 2. Then we compare v 2 and 3, and then 3 and 4. So now I'll ask, is I larger than the length, so we'll have to get the length of our vector, n, minus 1, because we do n minus 1 comparisons. Right? For a length 4 vector, we compare 3 elements. So in this block here, we'll set swapped equal to 1, and we'll also get the length. N equals the length of our vector. So is swapped equal 1? Yes. Reset swapped, set I equal to 1. Is I larger than n minus 1? If not, okay, if no, we'll ask the question, is v of I plus 1, okay, so that's, if I is 1, we're here, so now we're looking to the right, I plus 1, is that less than v of I? Is 10 less than 100? If the answer is yes, we're going to swap. So we'll move up. I'll label that as yes. We'll swap. Swap. And then we'll increment I, the iterator, I plus 1. And then we'll come back here. That looks familiar. That looks familiar. If you're following the previous example, this should look familiar. Now let's go back to this diamond here, and let's say, what do we do if the one on the right is not less than the one on the left? Well, in that case, we just don't want to swap, and we just want to continue on through our comparisons. So we'll short circuit the swap, and we'll label this as no. Let me move this up a bit. Delete this. Okay. Alright. So we say swapped equals 1. Is swapped 1? Yes. Reset swap. Set the iterator to be 1. That's going to keep track of our comparisons, where we're at in the comparisons. Are we at this one? Are we comparing these two? Or are we comparing these two? Okay, so we'll ask, is I larger than n minus 1? If not, we're going to compare those two values. Okay, swap if we need to be, increase the iterator, and go back. If the answer is ever yes to this guy, then we're at the end of the vector. And so we need to consider do we need to make another pass? Ooh. So we need to back up here. If I need to swap, I will swap, and I'll also set swapped equal to 1. So I'm going to squeeze that in here. So I'm going to write it in red. We need to set swapped equal to 1 right there to indicate that, yeah, we performed a swap. So now when the answer to this is yes, I'm at the end of the vector. Now we're going to ask the question, well, did I swap something? And if I did, then I need to make another pass. If I did not, then I stop and I return V, or VS if you like. So if not, we'll set VS equal to V. So our output vector equals our input vector now. VS equal to V, and we'll return that sorted vector. Okay. So now let's see if we've got the right flow, and we'll run through this guy here as an example. So I call my function, and we're going to say, we're going to keep track of swapped, and n and I. We'll keep track of those variables. So I call my function, we set swapped equal to 1, and then we're going to set also n equal to the length of v. So for this example, v is equal to 4. N is equal to 4. The length of v is 4. So there, I've got n is equal to 4. Now I ask the question, no, is swapped equal to 1? Well, according to our table, it is. So yes. So now I set swap equal to 0, and I is 1. And I come down here, I say, is I larger than n minus 1? Is I larger than 3? No. So I come in here and I ask, is v of I plus 1 less than v of I? Well, I is 1, so is v of 2 less than v of 1? It is. So I will perform the swapping routine. So this is my new vector. And I will set swapped equal to 1 to indicate to the while loop that, yeah, we're still swapping. Now I will increment I to 2, come back around, ask, is 2 larger than n minus 1? Well, n minus 1 is 3. Is 2 larger than 3? No. So I'll come down here. We'll say, is v of I plus 1, I is 2, so is v of 3 larger than v of 2, or less than v of 2? V of 3 less than v of 2. Yes, it is. So I will swap those. 10, negative 5, 100, 7. And I will indicate that, yes, we've swapped something. Well, swap is already 1, so I'll just leave it as 1. Now we increment I. I is 3. We come up here. Is 3 larger than 3? No. So there's still a comparison left to be made. So I come down here. Is v of 4 less than v of 3? So v of 4 is 7. Is that less than v of 3 is 100? Yes. So I perform the swapping routine. Okay, and I swap those guys and set swapped equal to 1. It's already 1, so that's fine. Increment I to 4. Is 4 larger than n minus 1? Well, n minus 1 is 3. So yes, it is. So that means I'm at the end of the vector and there are no more comparisons to be made in this pass. So yep, so I come over here and we ask, is swapped equal to 1? Yes, it is. So in that pass, I swapped something. So yes, so I need to make another pass then. So we'll reset the swapped flag to 0, reset I to 1. Is 1 larger than n minus 1? Well, no, it's not, because we reset I. So we come down here and we say, is v of 2 less than v of 1? So v of 2 is negative 5. Is that less than 10? Yes. So we swap. Negative 5, 10, 7, 100. And we set swapped equal to 1. Increment II. Is 2 larger than n minus 1? N minus 1 is 3? No, it's not. So we come down here. Is v of I plus 1? V of I plus 1 is negative 5. Sorry, we're down here. This is our vector. V of I plus 1 is 7. Is that less than 10? Yes, it is. So now I update my vector. Negative 5, 7, 10, 100. And I set swapped equal to 1. It already is 1. And I increment II. Is 3 larger than n minus 1? No. N minus 1 is 3, I is 3. So I come down here and I compare v of I plus 1, which is 100. Is that less than v of I, which is 10? No. So I don't do anything. I short circuit all this. And I increment I. Now I ask, is 4 larger than n minus 1? Yes, it is. So that finishes another full pass. So I come back here to this diamond and I ask, well, did I make a swap in that pass? So I looked at what swap is. Yep, I did. So I need to do this again. So I set swapped equal to 0. Look at our vector, by the way. Our vector is sorted, right? So let's find out what happens here. Set I equal to 1 is I larger than n minus 1. So I is 1, n minus 1 is 3. No. So now is v of 2 less than v of 1? Is 7 less than negative 5? No. So I short circuit the swapping routine, increment I. Is 2 larger than n minus 1? No. So I come down here. Is v of 3 less than v of 2? So is 10 less than 7? No. So I short circuit the swapping routine, increment I, excuse me. Is 3 larger than 3? No. So now I come down here. Is v of 4 less than v of 3? Is 100 less than 10? No. So I short circuit the swapping routine, increment I, excuse me. Is 4 larger than 3? Yes. So that's just another pass. And I didn't swap anything. So now I come back here and say, is swapped equal to 1? No, it's not, because I didn't swap anything. So then I say, okay, the output is now that vector that we were swapping, and I return vs. So this now becomes vs. And this is what we return, and that is the end of our function. That's it, right? Beautiful. So I want to point out a couple things here regarding the looping. So this function has 2 loops, and I can see that in the flowchart. Notice here, which I'll do in green, I come out here, whether the answer is no or yes, we meet up here, and then we revisit this box right in here. Right? So that's one loop. We had this box, we visited this box, the answer was no, then we came around here and we revisited that box. That's one loop. When our code was first executed, we visited this diamond here. And then we came this way, and after this full pass, right, we came back here and we revisited this box. So that's another loop. And because in order to answer this question, we needed to complete the loop in green, green must be the inner loop, because that has to fully complete before we can decide if we have to loop again. So this is the outer loop. Now, just like the previous example, this box here, put an asterisk there, this box here, put an asterisk, and this box here are all taken care of by the for statement. For I equals 1, 2, n minus 1. Because remember how the for statement works. It sets I equal to 1, which is this box. Then it steps by ones, which is this box, all the way until I becomes n minus 1. After n minus 1, when it gets larger than n minus 1, it escapes the loop. So that's this box. So those 3 green asterisks are all taken care of by this one for statement. Let me bring up the code, actually. So we coded this guy, and this was called my sort. Okay, there it is. So you can see, Now, since we did this previously, we have a couple different variable names. Here we're calling len as the length of v. Here we called it n. But you see on line 6, we've got the length. That's this guy. In red, I'll check. Then we set swapped equal to 1 so that we can ask this question, is swapped equal to 1? So that's, I'll put this in blue, that's the while control statement right there. So that corresponds to this blue loop here. This is the while control statement. So remember, that's loops while the control statement is true. So is swapped equal to 1? Check. So we've got that box. Then if yes, we enter that while loop. So we set swapped equal to 0. Now, just like we said, this green asterisk box here is taken care of by this for loop. So the next line is this for I equals 1 to length minus 1. That's what we've got. Remember that n is the length. So, yep, got that. Yep, got this next diamond, right? That's automatically taken care of by the for loop. So we ask that question there. And if that's true, then we did this swapping routine, which we've used quite a bit now. It requires the temporary variable. But we swap those guys, and then we raise the swap flag. That's this box and this box. Okay, so all of these things are taken care of now. We've got the code. We exit the if statement. See, and that's where the no meets up with the yes path. Okay, so if the answer to this was no, if the answer to the if statement was no, we didn't do anything. There's no else. So we don't do anything. We meet up again with the yes branch. That signifies the end of the if statement. Now we're to increment the iterator variable, but that's again automatically handled by the for statement. So this is the end of the for loop then. We come back around. So there's the end of the for loop. We come back around and we do that routine. And then once that's done looping, we're back to the while loop control statement. So that's the end of the while loop. And once we exit that while loop, we set the output equal to the input and we return VS. So returning VS is handled by the function header there. All right. So key points. First of all, what I want you to understand is this is not academic, and it's not here to just, you have to do this. It's to help you. It's to help you write your programs. And the pseudocode and the flowcharts are part of the design process, and they should be done prior to coding anything. Okay. I also want you to understand that in general, there's no specific form. No specific form for the pseudocode and the flowchart. There's nothing that you have to do there, but there are a few exceptions to that. They both, the pseudocode and the flowchart, need to be clear. And unambiguous is the key there. So when I give an example, right, we work through the example. Let's sort this length 4 vector. I can go step by step, sort that vector, see how exactly your code will, when implemented, sort my vector. Okay, so it has to be unambiguous, easily followed is the key. Okay, so they need to be clear and unambiguous. And then regarding the flowchart, there should be one start, which is at the top. Start at the top. Okay, and flow down. Flow down. Sometimes you see starting at the left and flowing to the right. So, or start at left and flow right. Any questions that you ask in the flowchart should be placed in diamonds, diamond-shaped boxes. Diamond-shaped boxes. And in order for your flowchart to be clear and unambiguous, the outputs of those diamond-shaped boxes should be labeled. In this case, it was yes and no. So label these boxes. Label yes, no. So we can easily follow your flowchart. And then finally, on the flowchart, a loop. I'll put this up here. A loop occurs when the flow, okay, if you're working through an example, visits a box that was visited before. So if we get to a box that we visited before, then we know we have a loop.